Hey everybody. Thanks for joining for the early birds that are on time. We usually wait a minute or two to let other people filter in. So we'll give it a minute, maybe a minute and a half or so, and then kick off into the demo at like 1:02 or something probably. In the meantime, you're welcome to drop into the chat where you're from, your experience level with Hex, that I can sort of set the technical depth of the demos or cover any specific things that you're interested in hearing about, or just say hello. If you wanted to say hi, that's fine too. And yeah, we'll kick off in a minute or two. Okay. I think we'll get started, and as more folks show up, they'll pick up where we left off. Okay. Welcome everyone to another How to Hex session. The topic of this one is flexible front ends for machine learning models, and I'll explain and sort of show you what I mean by that. Um, if you haven't been to a How to Hex session before, they're pretty simple. They are almost entirely demo. I don't have any other slides besides this title slide. We're going to sort of jump right into the product and do live demos for about 15 minutes. And then I'll reserve the latter 15 minutes until 1:30 or whatever your time zone is for any questions. You can sort of direct me around the tool, and I can show you how to do stuff. We can dive into some of the use cases I showed. The last 15 minutes are all yours. So I think without further ado, let's jump right into the demo. I did have another slide, but it just says demo on it. Um, okay. So today we're gonna talk about flexible front ends for machine learning models. And I think the easiest thing to do here is really just to show you what I mean with a couple of examples of hex apps. And then I'm gonna pop into the back end and show you how some of these are built. We're not gonna focus hugely on like the actual sort of data science like training model part of this. Almost all of these models are like very, very, very simple demo models. So I don't have expert advice for you on that today, but I'm going to show you how to really efficiently present these models and sort of operationalize them, make them available to your company, your org, your customers, etc. So this is kind of what I'm talking about. This is a Hex app that we'll look at the back end of in a minute. Um, and instead of being like a dashboard or sort of your traditional dashboard style report, it's more of this like tool that has a bunch of sliders and tick boxes and configurations that lets us basically input the values for a new user of, in this case, a telecom service. So this is using a like cell phone company data set. We can say, okay, we've got a user. They've been a customer for 12 weeks. They've used 1.7 gigs of data. They're only using like 7 minutes per month. They haven't already renewed their contract. They're not paying an overage fee. I want to know if this customer is likely to churn or not. And maybe I'm, like a salesperson who's about to hop on a call with this customer, or I'm just sort of browsing my list of potential calls. I click get predictions. Oh man, the model's 68% confident that this user is going to churn. That can kind of like inform my decisions. And then, okay, I'm looking at another user. They've been around for 73 weeks, and they have an overage fee of $10. What about them? 75% confident they'll churn. Oh man. And so you can sort of like twiddle through this and identify for a specific user how likely they are to churn based on a model that we've trained at our company. And there's a little bit more in this app about like the clusters that a user belongs to. So you can sort of group users into buckets. So this is an example of what I would call like a flexible front end for a machine learning model. It's not sort of deployed into a data pipeline like many machine learning and data science models are. It's something that you're actually exposing with a super simple interface to non-technical users at your company. Another great example, and this is actually something that we built off of a real customer use case for e-commerce, and we built it on top of this clothes data set. It lets you cluster a new user, and you can sort of like put in their various dimensions, the reason they're buying something for a wedding, and maybe they're looking for a dress, and we're there like 28 years old. We click predict cluster, and then it tells us what cluster they belong to, like what cluster of our existing users. And then it gives us some recommendations for items that they might like based on the kind of items that other users or other customers in that cluster have liked. And so you can imagine this powering like a real-time recommendation engine for an e-commerce website, or maybe for powering like an email to send, or for like a Stitch Fixie sort of custom shopper interface. We'll look at another one that's kind of fun that we built just for demo purposes. This has no real value. But this is that same sort of interface where you have some drop downs, some inputs. You can sort of set up your situation. This one is our Titanic passenger metadata. So maybe we're in third class and we're embarking from Queenstown, and we'll set it to child. We want to know what our chances of survival look like on the Titanic. And so we click our button, and in the background, a model is spinning up and running based on this information. And it helpfully informs us to not get on the boat because we only have a 25% chance of surviving. There's a bunch more examples of this across our customer base and internal demos. We see this pattern pop up again and again, where users will take usually fairly simple models like a forecast or a cluster, and expose them often inside of other reports to let people use sort of like machine learning assisted insights as part of their day-to-day job. So this is an app that is sort of a status report on HexSmart, a fictional e-commerce store, and it shows us our daily purchases. We can sort of drill into subcategories and maybe look at like electronics, which is all well and good. But then we also have access to a forecast that's using a simple model on the back end, and we can say, okay, I want to look at the next 11 weeks or 10 weeks out and see what sales are predicted to be like. We see this sort of spike with a slight trend down. Maybe we even expand it out to the far future, and we get that larger model. So I hope that all of these examples have sort of set that scene and explained what I mean about giving users, non-technical users, these really, really simple, no overhead interfaces into machine learning models that a data team has created. And Hex, I think, sort of uniquely lets you build these really, really, really flexible front ends that can look like this, where it's like a bunch of different options, and this is sort of a purpose-built tool. They can look more like this, which is kind of a hybrid of that, or they can look like something like this, where it's really mostly a dashboard or a traditional report, and then you have this one little moment that's powered by an ML model behind the scenes, and the user of this report doesn't care what's going on behind the scenes. They just want their forecast, and that's sort of the beauty of this pattern. Cool. So I think with the couple minutes I have left before we open it up for questions, I'm going to pop into the back end of a couple of these and show you how they work. We'll start with this one, I think, just since we're right here. So this is the app view. For those less familiar with Hex, Hex has both app views, which is what we're looking at now, where you can sort of build these reports and interactive tools. And then it has the notebook view, which is where the actual data analysis and machine learning model building happens. And the mapping is sort of from each one of these cells in the notebook, you have an element in your app that you can drag and drop and set up. So here we're looking at the back end. And most of this work is going to be relating to the charts and the data tables that we saw. So we're running some queries against Snowflake and pulling in data about purchases, running some more queries, building some charts. And then here we have this forecast, and we're using an input parameter, which is just a hex sort of widget to accept user input, to grab this input period slider. And then here we're building a dead simple model using Profit, which is a library developed by Facebook to do just like really simple auto ML on time series. And I'm kind of surprised actually at how many people use it in production. I often see it in customer production apps. It's actually pretty good and lets you tweak seasonality, put in your custom holidays, etc. So this cell here, this Python step, is really where the whole model training and prediction is happening. If we run just this step, and then we go up and change this slider, this step will rerun, our chart will rerun, and this sort of 3-cell block within our broader analytical report is responsible for that machine learning section. And then we can expose that in the app just as simply as we expose any of the other elements. So just like we can, add this chart or remove it from the app, if we take this out, all you have to do to expose this machine learning model in the front end is just drag in your asset to the right place, drag it over here, and we'll add that chart back in. Just like that, you've taken something that requires a fair level of technical aptitude to work with in this notebook and turned it into something that the end user doesn't even need to know that there's a machine learning model running. They just need to know, cool, this is my forecast. And this pattern is pretty much the same across all the apps, although the other ones are a little bit more complicated. If we look at this churn dashboard, you'll see kind of the same pattern repeat, but on a bigger scale. We're running a SQL query to grab some data, pulling it in. We're training here a random forest model and doing some data engineering or like upsampling the data, scaling it, etc. Just sort of your typical machine learning model creation stuff. And then, yeah, this simple Python step trains our simple model. And then we get this model output that we can use downstream in any part of this notebook and in any part of the app. And so here in the back end, you can see that we've actually been doing some evaluation on accuracy, precision, recall, etc. And we didn't have to take all of this work and copy the model over somewhere else to build the front end we wanted to expose. It's all actually running out of this notebook that we used to get the data, explore it, clean it, do some feature engineering. All we've done is not exposed all of this feature engineering and exploration work in the app. So it's this really nice pattern where you don't have to repeat yourself. You don't have to sort of scatter work across multiple places. You can work the way that feels efficient, all in the same place. Add in your widgets or your input parameters to accept user input, rig them up into some mechanism you can use to pass that information to your model, call your model, and then here we're actually doing some cool markdown parameterization to expose the results in text. And then if you just add this to the app builder, you get that interface that we were looking at earlier where you can expose this to non-technical users. One more kind of cool thing before we kick it open to questions. So this is just an example of the same thing, basically, where we have more of a standard analytics report where we have a chart of revenue over time. We have some filters that lets the user set up the segment they want to look at. And then we have a simple profit forecasting step here. The cool thing about this app in particular, if I remember correctly, is that if we look at the back end of it, I'm using a clever little trick here to allow for more diagnostics on the model to happen on the back end, again, in that same project, without slowing down the overall published app. And if we scroll all the way down, past our filtering, past our modeling step, and our plotting step, we have this diagnostic section down here where I'm doing some cross-validation. And I think I actually at one point had like a whole grid search hyperparameter optimization step here. And it took like 20 or 30 minutes to run, which obviously is not something you would want to have be part of your user-facing front end. And so I've gated it behind this run button. What this means is that if I run all the cells in this notebook, which happens when a user interacts with the published app, this cell actually won't run. So all the cells just ran. I'll run them again. But this long, complicated step doesn't run because I've gated it behind this run button with an if statement here referring to the output of that. And then if, I'm here working in the back end and I want to run some diagnostics, I can just click run diagnostics. I don't have to go drop into my sort of like dumpling sales forecast diagnostics project. I'm working in the actual project that I'm using to surface this model, but I can sort of do more behind the scenes, slower steps in it without worrying about slowing down the whole thing. So I know that was kind of a blitz through like 6 different apps and a bunch of different backends, but I hope it gives you a sense of this pattern that we see a lot of customers use where they build an app that sort of explores some data, presents data about the business or about a specific facet of the business, and then they also expose in that very same dashboard or report some kind of interactive machine learning model that does a forecast or a user cluster or a recommendation in order to operationalize that information without having to actually bake it into some backend pipeline and set up orchestration and deployment for that model. It's a pretty cool pattern. It's very efficient, and we see a lot of customers get a lot of like really, really fast value on it. Cool. And with that, yeah, we've got about 15 minutes for questions or diving into anything else. I'm happy to like go back and move slower through any of the specific things that we covered, or talk about completely different things altogether. So yeah, please pop your questions into the chat, ask them in the Q&A, and I'll get to them. Someone asked, are there any plans to add custom widgets to Hex? I would love a widget to allow the user to order some elements. That's a good question. I'm assuming you mean like custom inputs like this. We don't have immediate plans for adding custom user inputs, but I will say that I've seen people do some pretty creative things with components. If you're not a user of components, you should check them out. They're basically a way for you to configure little bundles of logic to expose to your company for reuse. So here we have actually like a bunch of little forecast components that are 3 or 4 cells. Doesn't exactly answer your question, but I've seen people build custom components that they sort of treat like individual widgets that might import like a bunch of packages and sort of do a more complex calculation and give somebody a couple options to interact with it all at once. Okay, another great question. What access do we have to fine-tune the backend architecture? Common frustration is that our data is large. Sometimes we need custom processes. Yeah, that's a great question. I'm glad that you asked it. So there's kind of 2 parts to the answer to this question. The first part is that you have a couple of really simple controls over the backend architecture. You can, for any project, change the image that you're running this on. And you can basically select from a couple of preset Python versions, or if you're on our enterprise plan, you can actually create custom kernels, basically like a Docker image that will run your notebooks on. So if you have some custom like low-level driver requirements or custom packages or something, you can basically send us a Docker file. We'll roll that into a kernel that you can access here and run your projects in. You also have access to control the size. And I think, again, upon request, we can bump this up to like extra, extra, extra large. I don't know how high it goes, but we have some pretty big kernels that we're running for folks on kind of an on-demand basis. The other thing I'll say, so that's one part of the answer, right? You can just literally scale up the Hex backend architecture to be, 128 gigabyte RAM server. The other thing you can do is if you're using Snowflake, and this works for BigQuery as well, but I don't have an example of it up, you can rely on Snowpark and Snowflake ML to run your training and your inference steps. And this project is actually using Snowpark with Snowflake to offload the heavy compute from the Hex kernel and push it into the Snowflake warehouse, which is like infinitely scalable, basically. So the back end, if you're not familiar with Snowpark, it might be a little more complicated. Um, but Snowpark is basically like Snowflake's version of Spark that lets you build these pipelines that compile to SQL and run inside of the warehouse. So here we're doing this inference step on this model that we're getting from the Snowflake model registry. And so when I'm running this Titanic inference step, Hex is like processing the inputs and building a user dictionary, but it's not actually doing the inference in a Hex server. It's passing all that information off to Snowflake where the model lives and where the data lives, and doing the inference there. This is really, really useful if you're using a ton of data, because you don't have to move the data around, which is very slow to sort of stream over the wire, and you don't worry about running into memory limits. There's a really, really, really great example of this in the Snowflake quick starts. If you go to quickstarts.snowflake.com and search for Hex, this churn modeling workshop, as well as this, well, actually, all of them are probably fairly good for this, but I think specifically this churn modeling one is a great example of doing this at really high scale. There's another one about credit card fraud or fraud detection that I'll find and send to you that's working on like tremendous amounts of data in a pipeline there. I hope that answers your question. You're welcome to reach out individually for more. A few more questions. Are there any other types of built-in charts on your roadmap? Yeah, we're always kind of working on improving our charts. It's kind of on demand. We recently added faceting, so you can build trellis charts. We can like pop this by rating, and then you get a trellis grid of a bunch of different kinds of charts. And yeah, we're always open to adding more chart types if folks request them, but I don't know if we have any specific ones on our roadmap right now. Did you have a specific one in mind? Okay, a few more questions. How do we integrate our data with your system? We have proprietary data sets that we need to pre-process before running this process. I'm not sure I 1000% understand your question, but I'm gonna try and cover it anyway. So the beauty of Hex, or one of the beautiful things about Hex, is that you do have some degree of control over where your data comes from and where the actual data processing happens. And most of the time, when we see people doing like, production use cases with Hex, they're hitting a data warehouse for their data. And here we have a bunch of Snowflake connections configured that our SQL cells can fire against. But you can run SQL cells against any kind of data warehouse or database. And so when you say like we have proprietary data sets, basically you can run a SQL query to pull those data sets into memories. So we'll say like start from demo data, and we'll grab like some electronics retail data, run this query to pull in the data, and then you'll have it available in memory inside of Hex. Yeah, there we go. So that's one way that you could do this. And some people prefer to just, like run a big select star. You get your 800,000 rows here in Hex as a data frame, and then you can continue to work and iterate on that data inside of the Hex project. And the cool thing about Hex is you can work on that data frame in Python, but you can also continue to work on that data frame with SQL. So we could say like, select event type, count star from data frame, group by one, order by two. That's like classic count pattern. You can keep working on it with SQL. So you can kind of pull all your data into memory and then continue to iterate on it. You can also decide to leave your data inside of the warehouse and then keep working on it sort of remotely. You can do this with either Snowpark, which I'm not going to dive into the depths of, but we were just talking about, or by returning a query. This means like, if we had 8 million or 800 million rows, which is too much for the in-memory kernel, or which would take like minutes to stream down over the wire from Snowflake, we leave it as a query, which shows you a 100-row preview but leaves the rest of the data inside of the warehouse. So no data beyond this 100-row preview has actually gone into Hex yet. And as we keep working on it, we can continue to work on this data with SQL. You can actually visualize it in charts, do like simple aggregations, and sort of keep pre-processing and building this, like processing pipeline in Hex without actually pulling all the data into memory. And all of this is being pushed down to the data warehouse. So there's no great way to show that in charts, but here, like for this query that's chaining onto it, if we look at the compiled query, we can see that it's actually being compiled into a query that's using a CTE to grab that first query and then roll it up in this new one. So I guess the synthesis of what I'm saying is like, you can just basically do all of the pre-processing inside of Hex proper in a notebook, like in memory, or for either like security reasons or performance reasons, you can choose to use query mode or Snowpark to basically leave all the data in your warehouse where it's already and do this sort of like lazily executed pipeline exploration in Hex and then sort of eventually run it all. Does that make sense, Glenn? Um, we have a few more questions. Question about combining Hex with things like Google Analytics or something related to SEO. I'm not sure I totally understand that question. You're welcome to reach out individually, just reply to the email about this event. I'm happy to dig into that. We don't have like pre-built Google Analytics examples. We do have, I think, a RudderStack example of using Hex on top of RudderStack's data, which is like a Google Analytics alternative. Yeah, RudderStack Web Analytics. This is live on our use case gallery, I think. I'll share this link with you here. So yeah, I mean, this is sort of a simple example of how you could rebuild a GA style dashboard. This is actually like an almost one-to-one rebuild of the old Universal Analytics dashboard inside of Hex using RudderStack. Now, it's all GA4 and looks kind of crazy, but if like me, you preferred Universal Analytics, check out this app and check out RudderStack and you sort of rebuild that process inside of Hex. Okay. Anything else? We've got another couple of minutes if you want to dive into anything more about model infrastructure, architecture, how to build and deploy these. Otherwise, I'll see you all later, and I'll make sure to include links to all these apps in the email that goes out after this, so you can play with them all yourself. They're all public. All the code is public. You can copy them into your workspace and use them as jumping off points to get ideas for your own Hex apps or understand how this pattern works. Cool. Well, if there's no other questions, then we'll wrap up a minute or so early. Thanks everyone for coming. This was really fun, and thanks for all the great questions. See ya.